AI Foundation series or AI Unlock series where we go for like over the entire foundations or the three pillars of artificial intelligence, the instrument of AI, which is Python, the melody of AI, which is data, and the symphony, which is machine learning. So this is season 2 where we're focusing on data science. We already went over season 1, Python for artificial intelligence, and now this is season 2, and this is specifically chapter 2 of season 2. The previous chapter we solved a couple of Python problems just to get ourselves warmed up for data science. This we're actually going to be diving deeper into data science, and we're going to be using a specific library known as the Pandas library. To install the Pandas library, just run pip install. You can always look up the documentation. And if you're going to be running it on your Jupyter cell, make sure you put the exclamation mark to actually install it. I'll be talking about virtual environments another time, but that's just a way for you to create isolated environments where you can create like specific isolated, like install specific packages or versions of specific packages for specific projects so it doesn't conflict with other projects. But right now, this will suffice since we're just practicing. So go ahead and install Pandas. Pandas, again, is just a library that is very useful for data analysis and just data science in general. So we don't have to code things from scratch like we did in season 1 or like we did in the previous episode. So just get started with that. All right, so first, let's start by creating our first data frame. So a data frame, you can think of it as, well, Excel spreadsheets, kind of. Like just a data frame is just a tabular 2x2 data structure, right? It's kind of like Excel spreadsheets. We human beings are very visual, so we like to see things in a very organized tabular format. Let me give you an example. So imagine I have a list, right? A list containing, let's suppose it's a dictionary, right? So let's suppose that we have a dictionary right here, and let's suppose that this dictionary contains a key called numbers, and let's suppose that the value is just going to be, well, a list of numbers, right? Well, let's suppose that the next key value pair is just going to be letters, right? So the value is just going to contain a bunch of letters. So we got that, and there you go. We run this code cell. We got an invalid syntax. Yeah, there you go. Okay. So now we just call this, and there you go. We have our dictionary that contains key value pairs, and each key represents what's going to be in our data. But this is kind of messy, right? We want this organized. We want to visualize our data organized, because imagine if we have a huge dictionary in that specific style. Well, that's not going to be very practical. So what we do is we use the Pandas library, which we defined as PD, and we call a specific method called the data frame method, right? We grab our Pandas library, and so the Pandas library is a toolbox, and we grab a specific tool called the data frame tool, and we pass data to this tool, to this method, to this function called random, which we already defined up here. What happens if we run this? Here you go. So we get our first data frame. Interesting. So as you can see, our numbers are actually our column names, and each column is obviously going to represent the data. So here, this column represents the numbers data, and this column right here represents the letters data. And of course, each row is assigned a specific index value. So that's what a data frame is. And what you can do is you can actually store this data frame, this mini data frame, to a variable, and then you can manipulate this variable however you want. So you can always call df and do whatever it is that you want with it, right? Let's actually read our data sets. Now I have a data frame, an actual data set over here called AI Engineering Dataset.csv. We'll talk about this little mini project that we're going to be doing later. But right now, let's actually read this specific data set called CSV that's going to be up here that I'll hook up to my GitHub so you guys can access it. But let's actually read this. How would we read this? Again, we call the Pandas library again. We go into our library, we get this tool from our toolbox, right? The Pandas library is our toolbox. We get a tool, but this time we don't call the data frame tool. We call the read CSV tool, because we actually have to read our file, which is a CSV file. If it was an Excel file, then we would call read Excel. Just look at the documentation. Now what happens when we actually run this? There you go. We actually read our entire CSV file. Now we have a huge data set. Well, it's not really huge, it only has 5,000 rows in it, but you get the gist of it. Now, if we store this to a variable called df, then we can manipulate this variable df to do whatever it is that we want. We can manipulate the data set, we can predict the data set, we can analyze the data set, we can do a whole bunch of things with it. So let's do that. So let's suppose that we actually want to read, well, we already read our data set, right? But let's suppose that we actually want to get retrieve the column name. So we can already see the column names up here. But let's suppose that we want it in a more explicit way, right? Then we call the columns method, or not the method. We don't actually put the parentheses there. We just simply put in dot columns, and then this would allow us to retrieve all of our column names. And this is good because this is a list. So this is a data structure, so we can actually index this. We can actually index this data structure. We can iterate over it to do a bunch of stuff with this column names. But yeah, that's how you actually retrieve column names. Another thing that we can do is we can actually retrieve the shape of the data set. So the shape of the data set is just specifically how many rows we have and how many columns we have. So here, the first value, which is 5,000, represents how many rows we have, and the second value just represents how many columns we have. Pretty easy. Now, what if we want to get general information about our data set, right? Well, to get general information about our data set, we have to call another method called the info method. The info method actually gets us, well, general information on our data set. As you can see, we have all the column names. It tells us how many rows we have, how many columns we have. It even tells us the data types of each columns, right? Each column can have its own data set, its own data type, integer, string, boolean, float, and that's what this general information method is going to tell you. It's also going to tell you how many missing values you have, but we will get to that later. But before we do anything else, let me show you one more method. Well, actually, there's many methods, actually. You got to look up the documentation because there's a bunch of things. Don't memorize any of this. The describe method. So the describe method, if you're familiar with some statistics, it's going to just give you a basic overview of the statistical information of our data set. It's just going to tell you, it's going to take all the columns that are numerical columns, that are quantitative columns, and it's going to give you a general statistical summary of the data set. So it's going to tell you the counts, the mean, the standard deviation, the minimum, the maximum, and the percentiles. And it's going to retrieve specifically the columns that are quantitative, right? So like the string values, that's not going to work. But again, we'll dive deeper into this when we get into more inferential statistics, but that's going to be a very useful method for just summarizing your data set. Okay, so yeah, let's talk about the .head method. Now suppose that you want to retrieve, because we're going to have a very large data sets, right? Oftentimes not 5,000 rows, but sometimes millions of rows, tens of millions of rows. There are really large data sets out there, which is why Pandas is very useful instead of Excel, because Excel has its limits. So if I just want to retrieve the first 10 rows of a data set, I could use the head method. So the head method is just going to retrieve the first 5 rows of our data set. If you pass the number 10 here to the head method, you can retrieve the first 10 rows of the data set. If you pass 20, you'll retrieve the first 20 rows of the data set, and so on and so forth. If you type in tail, that is the tail method, you're going to get the last 20 rows of your data set, or the last 5 rows if it's just tail. By default, it's just going to retrieve the last 5 tail, not the last 5 tails, but the last 5 rows. You know what I'm saying. There's another one called the .sample method. The sample is just going to retrieve random rows. It's going to retrieve any random rows from the data set. So if I pass in 5 right here, it's going to retrieve 5 random rows from our data set. By default, it's going to retrieve 1 row if I don't pass any parameters in it. But this is very useful if you want to get an accurate representation of your data set, just to get a general feel for the data set. At the beginning, you always want to get a general feel for your data set. Let's talk about renaming your columns. So if I want to rename my column, right? Let's suppose that we have our data set right over here, right? If I want to rename the first column, right? First of all, how do I retrieve the first column? Actually, before we talk about that, let me show you how to rename a column. You use the rename method, surprise, surprise, right? So to actually rename it, you pass a specific parameter called columns parameter equals, and then you pass a dictionary in it. You type in the old value of the column, which is response ID, I believe. Is that capitalized? I'm not even sure. Let's just copy and paste. Okay, because I'm not here to show you guys off my dyslexia, but anyways. Response ID, old column name, new column name. Let's suppose that we just want to get rid of all capital letters, right? So we just type in response ID. And that's literally how you rename your column. And look, Voila, your column is officially renamed. However, if I were to recall the data frame, it's not going to memorize, it's not going to remember that it actually changed the column value because we didn't store this algorithm. This is an algorithm right here. We didn't store this algorithm back to the data frame variable, right? So we actually have to store it back to the data frame variable for it to actually remember. Of course, you could always pass another parameter called in place equals true, and this parameter is going to allow the data frame to it's actually going to affect our df variable without us having to repass it again to the same variable. But you do you choose whatever method you want. I'm going to just redefine df right here. I'm just redefining df, so it actually affects my actual df. So if I call df again, let's call head, it's going to actually the changes are actually going to take into effect. Now everything I just showed you guys over here actually helps us solve the first half of our project that we have in here. I don't know if you guys noticed, but we actually have a project. So the first lesson in the project is to get an overview of your data, right? So over here, this is what we did. So let's just like clean this up. Let's clean up our cells. If you're following along, try to clean up your cells. Let's clean this guy up. So this is gonna help us get a general overview of our data set. Right here, one of the tasks was to print the first 10 rows. So let's just organize this over here. Yeah, over here. Right here it says to print the first 10 rows. Okay, so let's eliminate this guy over here, and let's put this guy down here. Okay, nice. So with df.head, print the first 10 rows of our table, and that's exactly what we did. Well, we printed the first 5 rows. If we want to print the first 10 rows, we pass the value 10 to the method head. Obtain general information about the table with one command. Okay, so that would be this guy over here. So let's eliminate this guy. Let's eliminate this guy for now, and let's bring this guy all the way down here. Nice. So now we're just organizing our stuff for this specific project. Let's eliminate this guy. A lot of these methods, you don't have to use all of them, right? There's just a bunch of methods in the Pandas library. I'm just showing you the most common ones, but you have to actually go and read the documentation and see. Don't think about what code. Don't think about the code. Don't think about the specific algorithms. Don't think about the documentation or the syntax. Think more about the general process of data science. What is the data science process? That's what you need to ask yourself. That's the main question. What does the entire process look like, right? Just how there's a scientific method, right? The scientific method, there's also the data science method, or the data science process, or the data science cycle. And that's very, very important for actual AI. So if we take a look at our project, stage 2 is now data pre-processing. So actually changing column names. Oh, interesting. So we already changed the first column name here. So let's actually get to that. So right here it says correct the formatting in the column headers and deal with the missing values. Then check whether there are duplicates in the data, etc., etc. So first things first. Stage 2 would be data pre-processing. So stage 1 is all about getting an overview of your data. And stage 2 is all about cleaning your data. So notice I'm not really talking about the project here, right? I didn't actually read the description of the project. I didn't, give a general information on what the project is about, because I want to abstract that for now and just focus on the data science process at the moment. We'll read the description in just a sec, but I just want to show you that this applies for pretty much any data set. You are always going to read a data set, and you're always going to have to clean that data set or make sure that the data set is clean, no matter what data set and no matter what the problem is. So, but here we actually want to style our column. This is the first step for data pre-processing in stage 2, right? The first step is about reading the data, getting a general overview, right? You read your data, you get a general overview of your data. You use the .info to understand the data types of your data set. Now, we enter stage 2, which is data pre-processing. If you haven't noticed, our data set is actually called AI engineering data set, And it's actually a sample, a simple 5,000 sample from a survey from apparently a 2025 Stack Overflow developer survey. Apparently, I honestly just generated this project with ChatGPT to like so that we can practice our data science skills. But yeah, apparently this is from a 2025 survey. It's a sample. Apparently, I don't know if the data is accurate. It doesn't matter for this purpose. This is just for us to practice. But let's actually begin with stage 2. We already through stage 1, so let's go to stage 2. Stage 2 is all about data pre-processing. So again, now it's all about actually cleaning our data set. So now the stage 1 was all about getting familiar with our data. So we ran .head to print the first 10 rows of our data set. We ran .info to get general information of our data set, so we understand the integers or the data types of our columns. We understand how many missing values there are. Now this is non-null. This is how many non-missing values we have. Not how many missing values, but how many non-missing values we have. So we have 5,000 rows. So if you see something called 5,000 non-null values, it doesn't mean that we have 5,000 missing values. It means that we have 5,000 values that are not missing. So that's a good thing. But we'll get to that. So here we have a bunch of columns, and like I said right here in the description, this is from a developer survey. You always want to ask yourself the question, when you're getting a general overview of your data, what does each row represent? Each row is an observation, right? So think of each row as an observation. What does each observation represent? What does each row represent? In this case, since it's from a survey, each row represents a survey response, right? And then you can start talking about the columns, right? You can get easily overwhelmed with this, but just ask yourself, what does one row represent? Does it represent one person? Does it represent one, I don't know, transaction? What does it represent? This case, it represents a survey, and this applies for all data sets. Always ask yourself, what does one row represent? This can get more complicated when we have a bunch of tables, and we start getting into databases, but yeah. Now that we understand that, moving here quickly, because this is just a crash course, we can really dive deep into this, but that's for the next episode. We already know how to rename our columns. I already showed you. How do you rename multiple columns? Well, it's actually pretty simple. All we have to do is put a comma right here and repeat the same process. Now, we can obviously automate this so that, all of the columns are properly formatted. But let's talk about that. What do I mean by properly formatting your columns? Well, here's the thing. You don't want your column names to be like this. You don't want this. You don't want a space in your column. You don't want that. If there has to be a space for, I don't know, making it easier for you to read, then you put an underscore. But that's it. You don't want actual spaces here. This also applies for naming your files as well. But yeah, just for convention's sake, you don't want a space, you want an underscore. The other thing is that you generally want you want your columns to be lowercase. So ideally you want this. You don't want capitalized letters, capitalized columns, ideally. But honestly, it doesn't matter, to be honest. I haven't really run into any issues where, my column names are capitalized and then I get an error. Honestly, not really. So, but, just for convention's sake, you could keep it lowercase. In our case, I'm just going to keep our column names as is. But now you know how to actually rename your columns. You can actually create a Python function for this. But like I said before, I want to create this crash course. You can really dive deep into this, but this is just going to be a short crash course on Pandas. So yeah, this is all you need to rename and format your columns. If it's a lot of columns you have, then create a function. You already know how to do that in Python. Just use the for loop. But let's move on. Alright, so I'm a bit of a rebel. I kind of want to skip this part because I don't think it's necessary. I don't see any spaces as long as there's no like special characters like this or this in your column names, or as long as there aren't any like spaces. And in my opinion, then you're good to go. It's properly formatted. Ideally, you would want everything to be lowercase, and ideally you want an underscore. But just, to follow this project that our, ChatGPT created for us, it apparently wants us to rename our string lower our column name. So let's actually do that. If you remember, you can call your column names with the dot columns attribute. So this is actually like this right here represents all of your columns names. If you call if you apply string lower to this, there we go. If you apply str.lower to this, string lower to this, you immediately convert every single column to lowercase. So that's just a quick hack that you can do. Obviously, this is like the most shortcut way to make all of your columns string lower. If for whatever weird reason you want to make only certain columns lower string, then you can create your own Python program for it. You can run a for loop. So for column name in for column name in df.columns, right? Because like I said before, you can iterate over each. Just to show you, you can iterate over each column name. So as you can see right here, I'm printing each column name, and you can affect it however you want. So we already talked about for loops in our previous season, so you can like literally create your own algorithm here. You can use regular expressions. So I haven't talked about regular expressions, but that's actually very important in Python, which we'll talk about another time. But regular expression is just a library in Python that allows you to find patterns in text. It allows you to find patterns in text. And you can use that library, which I highly recommend you go and read and check out. Very important. And you can combine it with a for loop or whatever to affect your column names however you want. You can maybe say, okay, only lowercase columns that start with the letter A, or only lowercase columns that start with the letter B. I don't know why you would do that. Again, I'm just giving you your options right here. But if you want to like just lowercase all of your columns, and my computer's about to die as always, then this simple line of code is enough. So with that being said, let's move on to missing values. All right, so missing values. So we already talked about formatting your column names. Don't spend too much time on that, to be honest. Missing values. Now this one's like the main problem in all of data science. Missing data. Now there's not much you can do with missing data, to be honest. Like there's not much you can do. The best thing is that avoid having missing data. Make sure you have as much data as you possibly can. It's easier to clean up your data than it is to, well, it's not easy to clean up your data, but it's better to have a lot of data and cleaning it out. It's just best to have clean data in general than it is to have like zero data, right? So you can't do anything with data at all, right? So if there's no data, there's no AI, there's no nothing. And that applies for pretty much everything. So make sure to avoid that. But to make sure you don't have missing data, you want to count how many missing data you have in the first place, or if you have any in the first place. So again, if you call our beloved data frame, here it is, then if you call the info method will tell you how many non-null values you have, how many non-missing values you have. But if you want to explicitly count missing values, then you use the isNa method combined with the sum method. That is going to give you the amount of missing values you have for each column. So the isNa method, all it's going to take, so each column right here, it's going to assign a true or false value for each cell. So for each unit. So like false represents 0 and true represents 1. So when you add the dot sum, so let's focus on this column right here, for example. It's going to count, so remember, when you add the dot sum, it's going to add up all the zeros, right? And it's going to add up all the ones, all the true values, right? So for this column specifically, it's going to add up all the zeros and ones. 0 plus 0 is just 0, so it's really just going to affect all the ones. So all the ones represents true. That is how many true represents how many that it's a missing value. So if this cell has the value false, it's because we have that value. That is, it's not missing. If it's true, it's because it is missing. So it's going to count all the ones. That is all the missing values for each column, and that's what it does. Pretty plain and simple. Now, how this description is saying it's pretty true. Not all missing values affect our research, but some of them do. So in this case, apparently converted comps yearly and job stat affects it. Apparently, I don't know. I haven't really looked much into this data set. I'm just trying to introduce pandas here. We'll do data analysis specifically in another episode, but I'm just here to introduce the pandas library. But yeah. So you can fill missing values, but you can't always do that. For example, if it's numerical missing values, sometimes you can you can fill those missing values with the mean. So like, let's see, what numerical columns do we actually have? So we have this column. Well, actually, no, that's the ID. IDs are useless. No, I'm just kidding. But okay, work experience. Let's call that. Let's call that specific column. By the way, you can call a column through the brackets, right? By indexing it, similar as how you would like index a list. So what are we talking? Oh yeah, work experience. Work experience. There you go. You got a bunch of values right here, right? Numbers. Sometimes what you can do is you can fill these missing values with the mean of the entire column, the average, right? Sometimes that's helpful. Sometimes it's not helpful. But you have to like do further analysis to actually decide what you're gonna do with that. But yeah, that's missing values. But just to follow the exercise, let's fill our missing values, right? How do you actually fill your missing values? Well, there's actually a method called the fill now method, and this method allows you to, well, fill missing values. Pretty self-explanatory. This is why I love the Pandas library. It's pretty simple. Like all of this stuff is really easy. So if I want to, let's suppose that I'm looking at, let's say, response ID 0 missing values, age 0 missing values. Let's look at employment. So employment, if we were to index this specific column, so right, this is our data frame right here. If we index employment, then we have access to the entire list, or to the entire employment column. Now this is actually interesting because it functions as a list. It's similar to a list, but it's not a list in Python. It's a series object, which is different. So in a list, you cannot call the head method, but you can in a series object, right? See, the same method that I'm calling in a pandas data frame, I can actually call it to a series object. So that's just a thing to note. But without diving too deep into that, I can call this a specific column and manipulate that specific column however I want to. So if I want to fill missing values, let's just fill any missing value with unknown, right? So I just call the fill none method and just pass unknown. Again, Pandas library is very simple. Like just look up the documentation. And there you go. So any missing values that you have, it's just going to be filled with unknown. Of course, in some kind of scenario, you could probably maybe, I don't know, use a large language model to fill missing values, but ideally you want to have like no missing values, right? But this is one way to do it with the fill now method. Whatever it is that you're going to fill the missing values with, you would use the fill now method. Right here I'm just labeling it as unknown. So again, you want to, if you do this and I call the column again and I type in isna.sum, it's gonna still show that I have missing values. That's because in order for this to actually be applied, I have to feed it back to the variable. So if I do this and then this, there you go. Otherwise, Python is not going to remember that you actually filled in the missing values. So that's how you fill in your missing values for a specific column. Now, what about numerical values? Same thing. So for a numerical column, let's suppose that we're dealing with what was it numerical? Oh yeah, work experience in numerical column, if I remember. So yeah, this is an integer data type, or float data type actually. So let's call this method. There you go, 625 missing values. So how do you fill this specific column? Well, all you have to do is fill none. And then just pass whatever number that you want to pass. Let's say that, I don't know, -1 represents missing value or whatever. So now we're gonna fill all missing values with -1. Or what I could actually do is I could fill it with the average of this entire column. So I think if I remember correctly, work experience. So I'm just gonna pass the column again, but I'm going to compute the mean. And there you go. So I passed the mean into the fill none method. So the mean method just calculates the average of the entire column. It adds up everything and then divides it by the number of values. That's the mean. So I'm passing that value to my fill none method. That way I'm filling all missing values with the average. That's a method that you could do, but it's not always helpful to do that, depending on how skewed your data is, but that's something we'll look at in data analysis. But yeah, now you know how to fill missing values. You can go ahead and do this for every single column. I'm just going to keep moving forward. You could also turn this into a Python script where it automates and it does it for everyone. But again, I'll leave that as an exercise for you. But yeah, that's categorical values and that's numerical values. That's how you do. That's how you handle missing values. At least the basics for both of those types. For both of those types of data. Duplicates. Let's talk about duplicates. How do you call duplicates? Duplicates, df.duplicated. There you go. That's how you call duplicates. So this is just going to count every single row in your data frame. So if we have our data frame right here, it's going to count if it's going to determine if there's a duplicate for this row. If there is no duplicate for this row, it's going to label it as false. If there is, it's going to label it as true. So if we run duplicated, that's what it's going to do. If we run .sum, it's just going to add up everyone and tell me how many duplicates we actually have. And in this case, we have 0 duplicates, which is good. It means that this is pretty accurate, right? Because this data set apparently represents, where each row represents a unique response from a user, right? So it makes sense that there is no actual duplicates. So, but there are going to be times where you are going to have duplicates. Sometimes there are going to be scenarios where a duplicate is what you would expect. But again, those are like rare rare circumstances. So, but ideally you would have no duplicates. Ideally each row is an observation, a unique observation. You can, however, have unique values in a specific column. So for example, in employment, I'm obviously going to have duplicates in employment. If I were to find the number of duplicates in employment, whoops. Okay, there we go. I'm going to see that I have 4,993 duplicates. That's expected, right? Because duplicates is just telling me, employment is just telling me the type of employment of a specific user, of a specific user. So obviously I'm going to find multiple instances of student. That's completely normal. But there are scenarios where duplicates do matter, and you shouldn't have any duplicates at all. But again, that depends on different data sets, right? That's why it's important to read your data set at the beginning, understand it properly. And sometimes you have to do all of this to actually understand your data set. Sometimes you have to deal with multiple tables, but let's not get ahead of ourselves. So that's that. Duplicates. Beautiful. And of course you can get rid of duplicates as well. So you can get rid of duplicates by removing duplicates. So there's a drop duplicated or job duplicates. Is that the method? Let me see. Drop duplicates. Yeah, job duplicates method. This is the method right here. I never memorize stuff, I just look it up. Drop duplicates, and that's simply going to drop all the duplicates in your data frame, if that's what you want to do. Or if you want to drop a specific set of duplicates, then you can drop the specific set of duplicates if you want. Like if I have duplicates, I can pass the subsets parameter, and I can identify duplicates based on only 2 columns, for example, or based on 3 columns, for example. If I don't pass any subsets, it's just going to base all the duplicates based on all of the columns, right? But I'm probably interested in only a couple of columns, so I could pass a subsets parameter to find how many duplicates I have for a specific set of parameters, of columns. But experiment with that and see, because I don't think this data set is going to have any duplicates. I mean, they are going to have duplicates where if I were to do it for specific subsets of columns, but they're not meaningful, if that makes sense. Alright, so now we're going to be talking about implicit duplicates. So, like I said before, I don't think our data frame has any duplicates because this is a sample data set from a survey, and if you actually look it up, let's actually look up this survey quickly. you're going to find, actually, let's type in CSV. You are going to find, you should find it here. Let's see, no, it's not here. What is the URL for the survey again? Let's see. There we go. Beautiful. So you should find it here. Now we have the download and we have the CSV. So you guys can actually like find the dataset right here in this URL. Just go straight to it. What is that? I don't care. And oh no, no, you should not see that. That's my invoice for my job. I do not want you guys seeing my invoice. But anyways, so here's where all the datasets are. So you should get a zip file right over here. Let's just open that up, and you're gonna get this. So this is gonna be where all the data is. This is the schema. This is gonna be like context of the data. But like I said before, ChatGPT created this for me as a sample, so it's not totally accurate. But again, this is just to like get us, you know, just for exercise purposes, right? Just to practice. I know I said that a million times. But yeah, so apparently we don't have any duplicates, any duplicate data. Either way, each row is an observation, and that would make sense that there is no duplicates. So we're good to go with that. But what about implicit duplicates? So here's the thing. Here's where like AI gets into. We can actually use AI in data science, and people need to talk more about this, using AI in data science, because this is really powerful. When ChatGPT came out, you know, we could easily just like copy and paste certain like questions, data related questions, and it'll generate the code for us. What we can actually do now. So let's talk about let's talk about implicit duplicates. Let me just explain what they are. Imagine we have, so let's read the description. It says right here, for some columns, different spellings of the same concept may exist. For example, the dev type column could include both ML engineer and machine learning engineer, describing similar roles. To get rid of such implicit duplicates, you can define a function, replace wrong entries, that takes a list, blah, 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 blah. Yeah, okay, whatever. I'm not much of a person that likes to follow instructions. I'm kind of a bit of a rebel. Probably why I didn't do very good in college, because you have to like, you know, follow to the letter the instructions, but not that kind of guy. I like to experiment and iterate. Some of you guys might relate. But let's look at this dev column they mentioned, right? Got a bunch of values right here. Now, how would we find implicit duplicates? Well, first of all, we need to find all the unique values that you would find in this column, because right here we're just seeing the column itself. So we're seeing we're seeing it as a series object, right? I already talked about what a series object is. We can do a bunch of things with a series object, like we experimented before. We could run the duplicated.sum to see if this thing has any duplicates. It's obviously going to have duplicates because, right, 4,967, but that's normal. That's what you would expect in the dev type column, because it's a survey. So you're only going to have a set amount of options. I mean, if you're going to have a bunch of respondents, well, obviously you're going to have duplicates in this column. But what about implicit duplicates, like what they're mentioning right here? You could have ML engineer, but you could also have machine learning engineer. Now, this is why it's very important to understand the context of your data set. This is where things don't get black and white in data science. Things are not black and white in data science. In the real world, things are messy, including data. Data is very messy, especially when we're dealing with AI, large language models, when we start training large language models, or when we start fine-tuning, or even creating retrieval augmented systems. Data can be messy. It can be very messy, and that is literally going to be like 80 or 90% of your job when you're creating these data pipelines or AI systems, which are basically just data pipelines. But let's open up this Stack Overflow survey. So this is the actual context that I pulled up here. Like I said before, I don't have much experience with this data set. Like, I've never actually done an analysis on this data set before. This is just to show you guys, to introduce you guys to Pandas library. But this is not a data analysis course. This is a Pandas library crash course. We'll get into data analysis soon enough. But let's see. So the def type column. Okay. Okay, we'll get back to this guy in a sec. How do we find implicit duplicates? So first of all, we need to find the unique values. So we use dot unique. Simple as that. Another method. Yeah, there's many methods in Pandas. Here you go. Bunch of values right here. These are all the unique values that you're going to find. That means these are all the options that the people who were taking the survey were able to introduce or were able to choose. So as you can see, we have developer full stack. We have developer. I wonder if we can find it in the thing. It's probably somewhere over here. Yeah, there's a lot of stuff here. We should be able to find it somewhere. Oh yeah, here it is. Yeah, this is probably it. Yeah, beautiful. Now, again, I don't think we're gonna find any implicit duplicates because, like I said before, this comes from an actual data set, and they probably made sure everything was already clean, everything was proper, everything was just pre-processed. But let's assume for a second that there's an implicit duplicate. So what would that be? What would that be? First of all, there's a lot of values over here. We could go each value, we can go over each value, like, just eyeball each value and just ask ourselves if it's an implicit duplicate or not. Or we can use AI. So how would we use AI? Well, if you watch season 1 of our Python series, we ended our Python series, the last episode of our Python series on season 1 in this entire AI Unlock series. We ended it by me teaching you guys the concept of the API, right? Application Programming Interface, and how to call or how to connect to the OpenAI API if you have a token, right? So you create an OpenAI developer account and you get your token, and you're probably going to have to pay a bit of money. It's not much, depending on how many tokens you're going to use, because it's based on how many tokens you use. You connect to the OpenAI API, and you can automatically start using the large language model and integrate it into your application. Let's do that. Let's see if our AI can actually, instead of us eyeballing it, let's see if our large language model can find any implicit duplicates or potential implicit duplicates. Again, things are not black and white. Most likely there aren't really any implicit duplicates, or if there are, or if it seems like there are implicit duplicates, there's probably a logical explanation, since, again, this is already a clean data set. But let's use AI nonetheless, and just to train our skills and just recap what we learned last time. So if we remember, we have to import the OpenAI SDK. So in order to do that, from OpenAI, import OpenAI. Let's see if that's actually the one that, because I don't remember this stuff. I keep forgetting a lot of this stuff because it's not good to memorize these things, which is something that college expects you to do, which is why I hate college. But anyways, enough with my college traumas. Anyways, so we also have to, I just realized that we also have to import OS in order for us to retrieve our environment variables. Actually, to retrieve our environment variables, we need both OS and load.env. So from .env import load .env. I think that's how you import. Yeah, okay, good. Let's just make sure that we can actually load our environment variables. If all of this just sounds weird to you, then again, I highly encourage you watch the final episode of our season 1. The one where we say make your first OpenAI API call. I highly encourage you watch that video if this kind of weird to you. But anyway, so we loaded our environment variables. We imported the OpenAI SDK. Now let's actually use it. So what's it called? It's called OpenAI, and let's just pass our API keys to it. So our API key is going to be what's our API key? Oh yeah. So OS, because we imported OS. OS has a specific method that we need in order to get our .env, which is called get.env. And our .env is stored in a variable in our .env file called our actual API keys are stored in a variable called OpenAI API key. And yeah, and that's how you initialize a client. And there you go. Beautiful. We're in OpenAI. We're connected to OpenAI. So let's actually store this connection into a variable called client. Awesome. Now let's start a new cell. Let's create a bunch of cells. All right. Now with this client, we can actually, use the OpenAI API. Now there's a bunch of documentation. There's the chat completions method, and there's also the newer method that OpenAI came out with. OpenAI developed. So again, we go back to the OpenAI developer platform, right over here. And let's just look at the documentation, because again, I don't memorize any of this stuff. I keep forgetting. Yeah, the responses method is actually the easier method that they came out with. It's really simplified their way to call stuff. But yeah, you can just like copy and paste this over here. We already imported and we already initialized the client, so we don't need to do all of that. Okay, so GPT-5, okay, that's actually kind of overkill. We don't need GPT-5. GPT-4o should do. All right, so here in our input, right, we don't want a short bedtime story about a unicorn. We don't want that. We want to find out if there are any implicit duplicates here, right? So in order to do that, let's rename this response variable implicit duplicates, right? And did I spell that correctly? Duplicates. Yeah, I think, okay. And let's pass, so if any of you are familiar on the concept of an F string, so an F string, so this is a string, we already know what a string is, right? So an F string is where you put an F right here and you're actually able to put a variable in your string. So when you input the curly braces, you can put a variable in your string. So for example, imagine that I have a variable called test and I have the number 10 in it. So it's an integer, an actual integer. So as you can see, I don't know if you guys can see it. As you can see, the number 10 appears here, right? So I defined a string, and if I store my variable in here, when I print this out, it's going to return the number 10, the value 10. Isn't that cool? So you can actually put a variable inside your string. This is very useful because we can use the concept of an F string right over here, right? Because right here, this is a string. Whatever it is that you're inputting into the large language model function, because remember it's a function, it has to be a string. But I can also input a variable into that string, right? I can input some kind of variable into that string. What are we going to input? What variable are we going to input? Well, this puppy right over here. So let's actually store this little program in a variable, this little procedure in a variable called columns. No, not columns. This is not columns. This is the dev type values. Yeah, dev type values. I don't know why I said columns. The column that we're analyzing is the dev type column. We want to find out if the dev type column has any implicit duplicates. And we're just going to get all the values. We run this guy, and we're going to pass it right over here. Beautiful. Yay. Now, again, just remove this entire text because we do not care about unicorns. And we can just say find any implicit duplicates in the following. And there you go. So, let me just clean this up. If we run this, we just wait. And while we wait, we drink some coffee in my pink cup. That's not my cup. Wait, and there you go. Sweet. And then let's just return this. And we have a bunch of stuff. What a mess. Well, let's look at our documentation. Oh, okay, so I can output my text like this. Beautiful. Okay. Oh, wait, no. Yeah, okay. Responses. Let's replace that. Okay, beautiful. That's also a bit messy, so let's actually print this. Let's wrap it in a print function. Beautiful. So let's see what our AI says. The list primarily contains unique job roles, but some roles might overlap in scope of responsibilities. These overlaps include blah, 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 developer full stack in combination of developer front-end, developer back-end, data or business analyst, and data scientists may have overlapping analytics. Okay, so let's actually, remember, when we're using AI, we don't want to depend on AI. We just want to work with AI, right? So let's actually, think critically. We're just using this so that we can simplify things and we don't have to eyeball everything. So apparently he says that, the AI says that developer full stack combinations of, developer full stack with combinations of developer front end. I don't see that as implicit duplicates. there's a clear difference between a front-end developer and a back-end developer, right? The front end, you deal with HTML, CSS, JavaScript, React, Tailwind, all that kind of stuff. Back-end developers deal with like Python, Ruby on Rails, databases, that kind of stuff. Full stack is, well, full stack, it's a combination of both. So I don't see that as an implicit duplicate. Excuse me. This one is debatable, but since I'm in the data industry, I know that there's a big difference between the three. So data scientist, business analyst, and just data. Now, this guy data right here, is that really in our, let's see, dev type values? So let's actually call this guy right here. I don't know if we have that over here. Data, is that in there? Oh yeah, data or business analyst. Okay, he's probably talking about this one. I don't know why I keep saying he, as if it was. That's a weird thing about AI. You keep calling it with a pronoun. That's anyways. Data scientist and data or business analyst. All right, so that's probably what it's talking about. It's talking about. Now, but again, for me, they're not implicit duplicates, right? So there's a big difference between a business analyst and a data scientist because a data scientist, again, they do overlap in the industry because like if you go on LinkedIn or something, sometimes they mean the same thing, but it's usually because people that are hiring don't know what they're talking about, which I don't blame them because like again, it's like okay, what is really the difference, right? But a data scientist, like technically speaking, there is a difference. A data scientist is so it's a data scientist, like an actual full stack data scientist, is mainly focused on like number one, cleaning up the data, number two, analyzing the data, and number three, like deploying whatever models that they created or that they're using. So that's what a data scientist is focusing on, and usually data scientists have like a huge like knowledge of statistics and mathematics, and a lot of real data scientists have like just a lot of mathematical and statistical knowledge. A data scientist, a true data scientist, is really just a statistician. I cannot talk today. A statistician. No, and a statistician. Yeah, there you go. A statistician. So technically, data scientists are really just statisticians or mathematicians that like applied mathematicians that know a lot of programming. But a business analyst is not so much of a statistician, but they're very good at quick, fast analytical results, which is what I talked about in one of my earlier videos. And that's really the difference between a data analyst and like a data scientist. So data analysts and business analysts are actually very pretty much the same thing. That's why over here they probably put data or business analyst because it's technically the same thing, but it is very different to a data scientist. Now what about this one? Cloud infrastructure systems. Okay, that I have no idea. I don't think they're implicit duplicates though. Now this one's interesting. Right here we have AI/ML engineer, and then we have right here developer AI apps or physical AI. That I'm not sure because again AI is a very new field. I build AI applications at the company I work for, so I don't know if I would be categorized here or if I would be categorized here. Again, that's probably, since this is a very new industry, yeah, that's something that still needs to be debated. But we'll leave that as that for now. Now this one's interesting. So engineering manager, project manager can overlap. Yeah, okay. I think there is a difference between those two though. Okay, so I think that's about it. So like I said before, I didn't think we were gonna find any implicit duplicates, because this data set is already pretty clean. But let's just assume that our implicit duplicates are, let's see. Actually, this one right here looks interesting. Project manager and product manager. Okay. So I'm pretty sure there's a logical explanation and for the distinction between the two. I am not a product manager. I am not a project manager. I'm an AI engineer. I have no idea what the difference between well, actually, I guess the difference is that a product manager is focusing on, well, the product, like specifically the product, while project manager is more on top, I guess. They're focusing more on like the overall project, like maybe the product plus the, I don't know, managing the advertisements, marketing of the product. I don't know. But let's assume that those are implicit duplicates, right? Let's assume that was a mistake. They probably mean the same thing. So how would we actually replace those, right? How would we actually replace those? Let's see. Well, I don't remember how to actually replace those. Let's use our AI. Hey AI, how do we replace implicit duplicates in pandas? Let's see what our AI has to say. No, I actually don't remember. It has something to do with the replace method, I believe. But this is why it's actually pretty interesting to code with AI. Oh yeah. Keep forgetting. All right. So, let's see if I remember. Drop duplicates. Yes. No, there's a replace function. Oh, the replace function. Okay. All right. Yeah, I mean, yeah, this is actually a way to clean duplicates. But we're talking about specifically implicit duplicates, like actually, replacing a value with another value. But now I remember. So you do this by using the replace method. So the replace method in pandas. So if you do df, and if you call the column, so the dev type column, and we go down here, okay, and you use replace. So here, what you would do essentially is you're going to replace some value, right, with another value. So if we say that our project manager is, like, let's suppose that project manager and product manager mean the same thing. Let's assume that's the case, right? They probably don't, but let's assume that's the case. I don't know why I have these tabs open. Yeah, okay. Let's assume that's the case. So some value, let's assume that that product manager, we want product manager and project manager to mean the same thing. So let's assume that product, actually let's just copy and paste. Product manager is the value we want to replace, and we want to replace it with project manager. So what's going to happen here is so the algorithm is just going to search over every single instance of product manager, and it's going to replace it with project manager. So when we run this guy, beautiful. Now you're probably not going to see much over here, but if we were to like call unique again, or you can store it into a variable and then call unique on that variable, it's up to you. We're not going to find any more product manager anywhere. Like, there is no product manager anymore, only project manager, which means we got rid of our implicit duplicates. So that's actually really cool. Now, again, you could create, I can see somebody, like, I'm sure it's already been automated, but like I like to think in first principles, but like what you can do is you could probably connect this with your AI again. Like, you can have your AI, like, you can apply this to every single column in your data set. This is just one column in my data set. We have like, what, 14 columns? We have a bunch of columns over here. So what you could do is I could see you like handling these implicit duplicates. So there's probably other implicit duplicates somewhere, maybe in employment or whatever. You could probably create a for loop. Like, I could see you creating a for loop and connecting that to your AI, so that your AI can handle the implicit duplicates for you. So let's see, how would we hypothetically do that? Well, we could probably iterate over each column. So like for column in df.columns, because that's how you would call call the column names, right? We could probably, let's see what we could do. I don't want to spend too much time on this because we gotta move forward, and I have this really bad habit of making long videos. Like, I'm to a point where I'm about to just give up on creating. I'm trying to create 10 to 15 minute videos. I'm not able to do that. I talk too much, but whatever. Implicit duplicates, client. Yeah, okay. So let's assume this is the case, and let's assume, how do we place, so let's find the implicit duplicates in the following. Let's do that, and let's do that, and let's do this. So for column in columns in df.columns, yeah, this guy over here, what are we going to do? We are going to pass column, so that specific column, and we need to index the data frame of that specific, like we need to retrieve the data of that specific column. So df column, right? Remember, column is just like, this is just a variable, right? So for example, it's iterating over each column, right? So imagine this guy right here is over here. So when it jumps to the next guy, it's gonna be, imagine age being over here. When it jumps to employment, it's gonna be employment over here, because it's iterating. It's jumping over each value. So that's what it's doing. So the AI is just going to complete this process in a loop. So it's going to, be doing a bunch of LLM calls. Let's see. And yeah, let's see what that's all about. Well, I just noticed something. df.describe. So these are all the numerical values. So responses, response ID. Okay. Oh man, my battery's about to die. Okay. We don't want to include the numerical values because, well, there's no such thing as implicit duplicates in numerical values. Actually, there are. If you have like a numerical column, but the numbers represent some kind of category, then yes, that could happen. But in this case, converted comps yearly, like this is not a categorical column. Work experience, that's not a categorical column. That's clearly continuous data. Now this response ID is, no, that has nothing to do with anything. Job satisfaction, that's on a scale of 0 to 10 if I'm not mistaken. But yeah, we would probably want to exclude the integer or the numerical column. So let me just quickly, so we have floats over here, floats over here, and floats over here, and integer over here. So let's exclude those columns. So exclude int and float columns. Okay. Interesting. I've never seen that command before. That's actually pretty cool. Ah, there we go. That's nice. All right, so let's use these. So whoops. Okay, what's going on with my keyboard? My keyboard is dying on me. Okay, there we go. Let's store, okay. Why is this? Okay. Copy, paste, okay. Let's store this. So categorical columns right here. And let's just copy this variable. Let's run this guy right over here. Let's delete this guy over here. Let's delete this guy over here. And then let's just replace it with here. Okay, good. And then, yeah, okay, good. So, beautiful. Now it's going to be dealing with specifically the categorical columns. And it's just going to iterate. And let's just create a simple for loop and see what happens. So, why is my keyboard? Okay, yeah. So, let's see. Print implicit duplicates dot output text. Wonder what happens. Again, you could like modify. Again, this is just a super simple for loop. Let's just This is just a simple for loop. Like you could create really cool things with this. Like look at that. So it's just going to it's going to like, yeah, that's really cool. So to find implicit or repeated throughout the list, the duplication is implicit in that there is repetition of the same categorical labels. For more, yeah, it's the analysis is not going to be super thorough. But this is still pretty cool. Like you can create some really cool stuff with this. Like I can see us creating a more complicated workflows. And this is actually, you can do this in NAN or in make.com. There's a bunch of AI tools out there that you can use. But I like to view things raw. Like I actually like to see how these tools work, how these agentic tools work, because this is AI, this is agentic, this is AI. Like there's nothing magical about. I mean, it looks like magic, but there's nothing magical about it. Like really an agent, when you look at all these NAN tools and all, they're really just like in principle, in its abstraction, a lot of it, these tools are just using Python. They're just using Python and like Pydantic, for example, for data validation. And it's really just like, I mean, it's not exactly this, but like, you know what I'm saying. Like it's, you can build these things, you can build these agentic workflows or these systems from scratch. But this is actually really cool. So like we used our AI to help us find some implicit duplicates. Now I'm not gonna read all of this because I don't want this video to go too long, and I don't want to hyper focus on implicit duplicates. It's not that important at the moment. But that was just something that's really cool that I found pretty interesting that you guys can like keep trying out yourselves. Just combining a little bit of combining a little bit of the sauce that we learned in the last episode of our season 1 series. So now let's continue to, solving these 3 hypotheses. Our first hypothesis. Developers who identify as AI or machine learning specialists have different job satisfaction compared to other developers. So again, this is a Pandas crash course. It's not a data analysis crash course. It's not a data science crash course. You can dive deep into this topic. Hypothesis testing. There's a bunch of statistical concepts that you would have to learn to just truly like digest all of this. Hence the different types of roles in data analysis and data science. But just to understand the basics and introduction of like pandas, so that we can jump over to the bridge of pandas from Python. How would we solve this hypothetically? How would we solve this quickly? So let's go to DF. Developers, right? Developers who identify as this has this compared to this. Okay, so we have 2 things here that they're talking about. We have developers, which is identified by the dev type column. Good. And we have job satisfaction. So what determines our job satisfaction? Okay. Oh yeah. Wait, no. What determines our job satisfaction? Okay, is it over here? The type. Oh, job stat. Okay, there we go. Right over here. Yeah, I am blind. Anyways, so we got this guy over here. Beautiful. And we have this guy over here. Right? So df. This guy over here. Nice. So how would we solve this? Let's see what so create this and then create, okay, okay, I don't care about that. So let's actually solve it ourselves without following instructions. No, I'm just kidding. You guys can follow the instructions if you want. That's why I created this Jupyter notebook. But dev type column. So developers who identify, okay, so we have developers right here who identify as machine learning or AI specialists. Well, let's look at all the unique values right over here. Who are the developers that identify as AI or machine learning specialist? We can actually use AI for this as well. We can ask AI, hey, what are, out of all these values over here, what developers identify as AI or machine learning specialists? And our AI can actually answer that for us, right? But again, I mean, it's not like our list is super long. It would be very useful if we had a very long list. But let's look at our documentation, right? So AI, ML engineer is pretty straightforward. So we got our AI ML engineer. We also got, what else? We have our, I guess these guys. I don't think anybody else. I mean, data scientist is definitely overlaps with AI, but it's more like broad. But yeah, for now, let's just include these two guys. So, developers who identify as AI or machine learning specialists had different job satisfaction compared to other developers. All right. create a Boolean indicator column is AI specialist. That is true. If this and false otherwise, we don't have any machine learning engineer, AI engineer. I mean, it's just these two. So that's fine. Group the data by this indicator and compute the mean of job satisfaction for each group. Okay, so what does this mean? So, no pun intended right there. So, job satisfaction. This is on a scale of 0 to 10 based on the survey documentation. It's just on a scale of 0 to 10. That's the score. Now, here's the thing. We have a bunch of NaN values. We have a bunch of missing values. So this goes back to our missing values, right? Handling missing values. What can we do right here? We can actually just leave it as it is, or because it's a numerical thing, we can fill these missing values with the mean of the entire series. How would we do that? Well, again, like I said before, we can use the fill num method, and what we can do is we can fill it with the mean, right? So how we calculate the mean? Well, you call the column, and you call the mean method, and that's it. And there you go. And there you go. Everything, all the missing values are filled with the average. So this is the average. Again, that's just the gist of it, like the basic stuff of it. But anyways, and we could store this to a variable as well. We want to store it back to the job sat column, so the changes actually take into effect. But yeah, so now that that's dealt with, right, if we were to hypothetically call this guy again, oh my goodness, what's going on? Okay, my keyboard, I need to get a new keyboard. No missing values. Beautiful. Now we can actually do stuff with this. So we can actually get the mean of this entire thing, right? Beautiful. So this is our new mean. So our old mean was actually what we used to fill the missing values. This is actually our new mean. Now, this is interesting. Now, we want to specifically call the def type column these are all the def types. And our data frame, what our data frame is telling us is this is each observation. This is a unique survey response, right? So this is a unique survey response from the individual. And if I'm not mistaken, each row represents a unique individual. I'm not sure if it's a unique individual or a unique survey response. I know it's a unique survey response, but I don't know if that includes also unique individuals. It probably is. It probably is. Yeah, I think it is. But either way, let's just like move on, because I don't want to like take too much time. How would we solve this? So all of this tells us how many users there are, right? 5,000. Again, it's a sample. So what we would do, there is a very interesting method called the group by method. So if I type in group by, what this is going to do, okay, so it's going to take it's going to literally, like, remember when we called the .unique method? .unique. So it's going to take every single unique value right here, and it's going to find all the, so for example, it's going to first take a look at developer, right? And then it's going to compare it with another column. The column that we want to compare it with is the job sat satisfaction column. And it's going to, so let's just like, it's going to take that column and it's going to compute something. So just something. It could be anything. It could be the sum. It could be the sum. It could be the mean. It could be anything, really. It could be another function even. For now, let's just compute the mean, right? So actually, just to make things more explicit and simple, let's compute the sum. So, and we're going to take, so actually, I actually don't remember the order of this. So dot sum and the dot def type column. So we're going to take the dot group by, and what we're going to do is we are going to pass the def type column. So this guy right here, if I remember correctly, the def type column here, it's going to group by the def type column. Yeah, this is not how you do it. Now that I remember, actually, so you take the job stat column and you're going to group by the def type column. P, there you go. And we're going to compute the mean. And there you go. So yeah, that's how you do it. Okay. So what's going on here is we're taking this column right here, right? And this method right here, what it does, it takes all the unique values in this column right over here, the unique values we were analyzing earlier, and it's going to just compute all the unique values, and it's going to group all the job stat values. So it's going to associate all the scores of AI/ML engineer, all the scores that correspond to AI/ML engineer. It's going to group it. It's going to put it, like, imagine you have a bag. It's going to group it to that bag that corresponds to the AI/ML engineer. It's going to go to the next unique value called academic researcher, and it's going to find all the values that correspond to academic researcher. So for example, if we go back to DF, so let's look at this first row. This first row, if we go to dev type, is called developer full stack. So there's going to be a bunch of other rows that also have developer full stack, right? So this row also has developer full stack. So this developer full stack has a job satisfaction value. In this case, it's empty. It has a missing value in it. Which, yeah, it has a missing value in it because we didn't fill those missing values. We need to actually fill those missing values. But anyways, oh yeah, we did. Okay, it's right here. Okay, there we go. Good. Oh, okay. So okay, I see what's going on. We actually created a new column. I didn't mean to do that. We created a new column. Yeah. By the way, when you this is why you should always check your values. You might accidentally create a new column if you don't rename it properly. So our real column name is capital J, capital S, but we didn't add a capital J. That's probably why, convention wise, you want to like lowercase all your column names so that this kind of stuff doesn't happen, but whatever. So let's just correct that. Dot, and yeah. Either way, nothing is effective. So if we were to run this again, there we go. Yeah, now our actual job stat is going to have those, filled in values. Yeah, that's my huddle notification. Oh yeah, it's a 10. Jeez. I'll be right back. So, yeah, that's our DF. That's our data frame. Yeah, so these are our values, right? So let's just ignore this column. Actually, let me just, yeah, okay, yeah, let's just leave it as that. So we can also drop this column if we want. Anyways, the point is we accidentally created that column, but that's fine. It is what it is. So point is, what is happening right here, so this is going to be a bit confusing for some of you, but it's fine. Like, it's going to look at this column because this is what's happening. It's taking a look at this column, dev type, right? Dev type, beautiful. It's going to take a look at this value first, right? So it's going to take this column, it's going to find all the unique values, and it's going to iterate over each unique value. So, for example, let's suppose it's iterating over, it's at developer full stack, right? Developer full stack. So this row has developer full stack. This row also has developer full stack, and this row also has developer full stack. And this row has a corresponding job satisfaction value. Again, ignore this column that we created earlier. Has a job satisfaction value. This row also has a corresponding job satisfaction value. and this developer full stack also has a job satisfaction value. So what's going to happen is it's going to take all the developer full stack rows, and it's going to group all of the corresponding job satisfaction values. All the job satisfaction values that correspond to developer full stack, right? So for example, this guy right here, academic researcher, it's not going to include that value. It's only going to include that value if it has developer full stack, if that makes sense. So it's going to take all the job satisfaction values of developer full stack rows and group them all together. Imagine it's all grouped together in some kind of in some kind of memory, in some kind of data structure, a list, dictionary, whatever. They're all grouped into some kind of storage. And it's same applies to academic researchers, same applies to everybody. So let's remove this dot mean. So right here, when we remove the dot mean, this is our object. Every single unique dev type now has all those job satisfaction values grouped. And they're grouped by dev type. Now, what do we want to do with all those group values, right? Do we want to add all those values up? So do we want to do dot sum? In which case, we could do that. And what's going to happen is all those group values that correspond to developer full stack that we grouped together, we can add them all up and we get a single value. And we can do the same thing for the other columns. So sorry, for the other values, not columns, for the other values. And we can add them up. But we don't just have to add them up. We can also do anything with them. Adding up is just one of the aggregation methods that we can apply to it. We can also apply a mean aggregation. They're called aggregations, by the way. And this is what we want to do for solving this little guy over here. So why? Why is this important? Also, what we can do is we could call another method called sort values. There's just a bunch of methods in Pandas, I'm so sorry. But it simplifies things, because imagine you having to code this from scratch in Python, right? This is why you use libraries. If you sort your values, your values are going to be sorted. It's pretty straightforward. Of course, it's sorted from, the top guy being the least and the bottom guy being, so we can actually, reverse this. So we can, put ascending equals true or false, actually. And there you go. Now it's sorted from greatest to least. Nice. So now we can see the top 10 values, or the top 5, or the top whatever. So what does this tell us? This tells us that those who are AI/ML engineers have this score, right? And those who are developer AI apps or physical AI, or who identify with that role, has this score. What does this tell us? It tells us that these two roles that we were talking about over here are in the top. Let's see, top what? Are they in the top 5? Let's use top dot head. Everything starts to connect, right? Remember we used the dot head method at the beginning. Since this is a series object, we can use a top head. Yeah, okay. So yeah, look at that. Developer AI apps or physical AI makes it to the top 5. Not only that, it's actually in the top 3. If we do top 10, look at that. AI/ML engineer appears. That's really cool. So that probably is, it's evidence that developers who identify as AI or ML engineer specialists have a pretty high, on average, satisfaction, job satisfaction score, on average. Of course, again, you can dive really deep into this, because this is, now we're getting into statistics, because the next question would be, okay, is this actually meaningful? Like, for example, is the difference between this value and this value really, like, meaningful? Obviously, AI/ML engineer has a higher, on average, job satisfaction than data engineer. But just because it's higher doesn't mean it's significant. There's a big difference between the two. Again, now we're diving into data analysis and data science, and that's not the point of this video. But that's something that you can get into, and this is something that, this is why data science, there's a big difference between being an actual data science, because technically they're statisticians, and just a regular analyst. So if we're just making quick, fast decisions, we can automatically conclude that, oh yeah, so AI/ML engineer has a greater job satisfaction. But we don't know if that's actually significant, because number one, we're pulling this from a 5,000 sample. We probably need a much larger sample. And number two, it doesn't necessarily mean that there, like, the difference between this value and this value, it doesn't mean it's significant. There could be anomalies to this, right? That could explain why one is higher than the other. And this is where the concept of like hypothesis testing comes into play, and to actually find out if there's any significance. So, but again, that's more data science, and we'd probably dive into that another time. Hypothesis 2, AI adoption differs between countries. In particular, we will compare the United States and India. So, okay, that's the hypothesis. How would we solve this? Let's see what the description says. The AI select, AI model's choice. So we'll need to filter this with this. Oh yeah, okay, we want United States and India, so like let's do that. Oh yeah, so there's some instructions over here in these comments, but like let's ignore that because like, whatever. And let's retrieve the country column. Ah, beautiful. So we have missing values. Of course we have missing values. So that's actually concerning that we have missing values in this one. And this is where data cleaning and data pre-processing like really gets messy, because if we have missing values over here, there's not much that we can do. All we can do is just fill it with unknown, because like what are we gonna do really? We can't. This is not the same as numerical values. We could probably fill it with like the mean, for example. Oh, by the way, mean is not the only thing that you could fill it with. You could also fill it with the median, which is different to the mean. But again, that's more data science that we'll get into another time. But categorical values is different. It's a lot harder because I can't predict if someone comes, if someone's from Germany or if someone's from France, just, by looking at the survey response, right? So we can't really do anything there. So, we just have to fill it with unknown. Make sure to copy this guy exactly as it is so we don't end up creating a new column like we did last time. And there you go. So there you go. It's all filled with unknown. So if we call isNa.sum, it's going to compute 0 because it's not going to count unknown, because unknown is just a string value. Good. So let's filter by... Okay, so filtering. I actually haven't talked about filtering. This is really important, and you're going to be doing this a lot. There's many ways to filter. My preferred method, for some weird reason, because I'm weird, is just, so if I want to filter by United States, for example, you would put df country equals United States. United States. I think that's how. Okay. Why the double equal sign? Remember, there's a big difference. Remember from our Python series, there's a big difference between double equals and the single equals. The single equals, you're just assigning a value to a variable. Here, we're not assigning anything. We're not assigning United States to the variable, to this variable. That doesn't make any sense. We're just comparing, or we're just trying to find, so like, if I say test equals 7, what I'm doing here is I'm assigning the value 7 to the variable test. But if I say equals 7, like double equal sign 7, what I'm doing is I'm comparing the already stored value in test to the value 7. That's the difference. So like, if I have test equals 8, and I run test double equal 7, it's going to return false because 8 is not equal to 7, right? So that's a big difference. One is for defining a variable, the other one is for making comparisons. Here we are, what comparison are we making? We're trying to, so since this is a series object, what we're actually doing, in essence, is we are iterating over the entire column. So behind the scenes, because it's a series object, it's going to compare every single value to this value, and it's going to see if it's true or false. If we actually have United States there, and it's actually going to return it for us. So it's going to filter by United States. So yeah, as you can see, it's going to compare it's going to look at the first value, and it's going to see, hey, is this United States or not? Oh, it's not. Okay, let's put false to this. Let's assign false to it. Is it United States or not? No, false. Okay, is it United States or not? False, and so on and so forth. But we actually want to see the rows that actually represent United States. So for that, we actually have to wrap this entire thing in brackets, and we call df, because we're calling the entire data frame. We actually want to call all the rows that have United States in them. And nothing. There are no rows that have United States. What does this tell us? It tells us that maybe this is not how United States is named. Maybe it's the United States, or maybe it's United States of America. There's only one way to find out. So let's go again and type in unique. And let's look for United States. And if this is a super large, thing, then what we could do is use AI to find our United States value. But I already found it. Here it is. United States of America. There you go. United States of America. Oh, there we go. Fixed it. So we have 741 rows that represent United States. So these are all the users that represent United States. Great. And what we can do is we could store this to a variable. We could call it USADF. And let's do the same thing for India. So for India, it's going to be the exact same thing. So we could say India df, and then just copy paste this. I'm going to just change this to India. And let's just make sure that we actually returned any rows. No? Oh, wait, we misspelled India. There we go. Sweet. 242 rows for India. All right. And there you go. So now we have our data frame that contains only USA responses and our data frame that contains only India responses. So now, so let's remember what we're trying to do. AI adoption differs between countries, specifically USA and India. So AI adoption. What column represents AI adoption? Let's see. What does our instructions say? Within each country, compute the counts of respondents excited about each AI tool. AI select and the counts of preferred AI models. Okay, so there's a problem here because AI models choices actually doesn't represent AI models, because if you actually take a look at the AI models choices column, you're going to see that this is actually just it's just a yes or no. So no, this does not represent AI models. I'll have to fix this. Because if we actually look at our documentation, I can tell why our AI model thought that when I created. I can tell why ChatGPT thought that when I created this little project with it. But what it really represents is this specific question. So let's see if we can find it. Let's see if we can find. Wait, is it this one? No, it's not this one. Is it this one? No, it's not this one. Let's look for. Oh yeah, it's this one. Did you utilize or integrate specific large language models to power your development tools or applications in the last year? Here we are referring to models like GPT-4, Llama, Claude, etc. within your development environments or solution. Yes, no, I don't know. So that's what this is representing. And for AI models specifically, this one right here, that's another column that this data set that we have does not include, but it's definitely included if you were to actually download one of the data sets over here. So so ChatGPT didn't include it for some reason. That's kind of disappointing. But for now, we can work with these. Either way, if you want to do a deeper analysis, download one of these data sets and play around with it. That's the best way you can actually improve. But for now, let's just use this to actually answer the question, that AI adoption differs between countries. Now that we actually understand what these yes or no means, like what it's actually answering. Just answering this one right here, if I'm not mistaken. So let's see how this differs between USA and India. So USADF, if we filter by the column AI models choice, right, what we can do is there is a very cool method called value counts. what this method does is it takes the unique values. It's kind of like the group by method. So it basically takes all the unique. So for example, here we only have like yes, no, and nan. So it's going to take all the yes values and it's going to just group them and it's going to count them, right? Because remember, we're dealing with categoricals here. So it's going to group them all and it's going to count them. And it's going to take all the no values and it's going to group them and it's going to count them. So let's actually compute that. There you go. So we have 343 yeses and 325 no's. That's specifically for USA. So we can actually store this in a variable and call it USA distribution, right? And we can do the same thing for India. We could say India distribution. We could do the exact same thing. India df. Beautiful. Now we can actually compare. So we have USA distribution. Nice. And we have India distribution. Interesting. So now we can actually compare and do an analysis. So like, for example, we can see that, well, obviously we have more, apparently we have more respondents, well, more USA respondents than we do India, but that doesn't tell us anything. So what we can do is like, we can say what is the percentage of yeses relative to the total, right? So like, remember, we could actually index this. So like I can do 0, and this is going to retrieve all, 343. These are all the yeses, the number of yeses, right? 343, right? 343 yeses. So index 0 is for yes, index 1 is for no. So like I could do index 0 divided by, put this in parentheses, index divided by the total, which would just be this. So this is the total, right? The total is just yes and no, right? So yes plus no, that's the total. So all of this is the total. And we're taking yes and we're dividing it by the total, so we can get a percentage. And that's our percentage. So 51%. We can actually, put all of this in parentheses and multiply by 100. Beautiful. That's our value. 51% for yeses in the USA. So we could actually put an F string right here and say yes percentage USA. And we could store this in curly brackets. And there you go. Let's actually print this. So yeah, that's actually pretty cool. So yes percentage USA is 51.34%, and as for India, let's do the exact same thing. India would be, so we change this, change these values. Okay, what did I do? Okay. Yeah, of course I did that. Nice. Okay, so the yes percentage is in India is 69.78%. The yes percentage in USA is 51.34%. So that should tell you something. Again, you can dive deep into this. Data scientists are very skeptical, so you just really dive deep into this. But yeah, with this you could actually draw some conclusions that on average there's more AI adoption apparently in India than there is in the USA. Apparently, from this sample. Again, this is just a sample data set. Nothing really significant here. And yeah, that's really cool. So hypothesis 3. Let's move on. Final hypothesis, and then that concludes this little Pandas crash course for you guys. Respondents who use AI tools earn higher compensation than those who do not. Is this true or not? Who the heck knows? I'm just kidding. Let's find out. So DF. Use AI tool. Okay, what's it asking? Oh yeah, okay, AI respondents who use AI tools earn higher compensation. What's our compensation column? Oh, it's this one right here. Yeah, it's this one right here. This one right here is our compensation column, and this one right here. Again, you could automate all of this with AI, which we will do later on, but we need to get the fundamentals first. Let's see. What are we talking about? Who use AI tools? What column represents AI tool use? Wasn't it the one that we were working with? No, the one we were working with is, did you utilize? Yeah, this is more specific. Like, did I actually use it in my development environment? Not that I use AI tools. Oh, this one's I use AI tools. The AI select. Yes, I use AI tools. Yeah, this is the one. Okay, good. So let's use this one. Oh yeah, and our description mentions that. Oh no. Yeah. Okay, it does. AI select. Okay, nice. So let's use this column for AI use tool. AI, usage tool. That I use AI tools or not. Okay, so respondents who use AI tools. So what values represents respondents who use AI tools? Let's look at that. So we have multiple responses. Yes, I use AI tools daily. Yes, I use AI tools monthly or infrequently. No, I don't plan to. Yes, I used AI tools weekly, and no, but I plan to soon. So I could say that maybe this, and this represents uses AI tools. Yeah, because we're just specifying those who use AI tools. We're not specifying if whether they use AI tools frequently, right? So what do we want to exclude? We want to exclude this guy. We want to exclude this guy, and obviously the NaN values. So how do you exclude these values from our analysis? Well, before we exclude, how would we calculate this? Well, again, this is a simple group by method, right? So we group by the, so we actually switch these two, and we group by df.select, right? And we compute, let's compute the mean. So we compute the mean. So if we do this, why do I keep missing the P? Okay, there we go. If we do this, this is what we'll get. So let's see, respondents who use AI tools earn higher compensations than those who do not. So no, I don't plan to. This is their compensation, their average compensation. No, but I plan to soon. This is their average compensation. Yes, I use AI tools daily. And okay, so let's see. Yes, I use AI tools daily is greater. Okay, that's interesting. Okay, that's actually pretty cool. They don't seem to differ a lot, to be honest. But again, this is where you would do a statistical statistical test. Why cannot I not respond that? I cannot talk today for some reason. I cannot pronounce. I can't speak English today. But anyways, this is where you would use statistical testing to differentiate between, these values and these values, because, by the looks of it, they don't seem to differ by a lot, but there is still a difference, right? And it seems like on average, these guys tend to have, a higher compensation, a higher compensation than these guys over here, which is very interesting. The only interesting thing is this guy, so the one that uses tools weekly, is actually less than these two guys over here. So that's actually pretty cool. You would think that the weekly guys are going to be higher than the ones who use AI tools monthly or infrequently, but that's actually interesting. For this guy makes sense. I mean, if you use AI tools daily, yeah, you would expect maybe for it to be higher, maybe, I don't know. But that's something that you could dive deeper into. But for now, I just wanted to introduce you guys to some basic Pandas methods. The group by method, how that works, mean, sum, how to look at your data frame, the concept of implicit duplicates, handling missing values, duplicate values, renaming your columns, the entire data science process. So this entire thing is the data science process. Like, you first read your data, you clean your data, you find any missing values in your data, any duplicates in your data. Like 80% of it is really just cleaning up your data, right? Now, this is obviously a very ideal data set. This is a very clean. This is already a clean data set, by the way. But this is just to get you guys started. This is just to like so you guys can start playing around with this and dive deeper. But here's the thing. So I don't want you guys to memorize the Pandas library. I don't want you guys to study everything related to the Pandas library. There are things that I still don't remember. Like seriously, like there are things that I still have to look up. Like if I need to look up a specific way to filter data sets, like there are many ways to like there's literally a method called the iLock method. So the iLock method in Pandas, that's another way that you can filter data frames. There's just a bunch of documentation. Like you can just go into the Pandas documentation, you can just find so many things, so many methods. You're not supposed to memorize this. It's just a toolbox, right? What you need to focus on, if data science is what you like, you need to study the data science process. That is what you need to really dive deep into. Study statistics and mathematics. Because then you'll know what you're looking for. Then you'll know how to ask the right questions, right? So then you'll know, oh, okay, so in order for me to test a hypothesis, I really need to make sure that my data set is clean. If you understand your data set, you'll know what duplicates should count in your data set and which duplicates shouldn't count, because it's going to vary between data sets. It's going to vary between different tables. You're going to have situations where you actually have a huge database with a bunch of tables in them, right? This is just a very ideal scenario. So that's all of that stuff. You need to learn how to ask the right questions. But to understand how to read, how to ask the right questions, Pandas is not going to answer that for you. Pandas is just a library of tools. You're going to have to ask those questions yourself. That's where mathematics comes into play, and understanding the data science process, which is like the scientific method, comes into play. Because once you know how to ask the right questions, then you'll know what tools you need to use or look up, right? That's the difference, right? So a good analogy of this is, if you're in construction, you don't need to like memorize every single toolbox name, or like memorize or have every single tool right here with you, right? No, I mean obviously not. But if you know how to build what you're building, if you know what you're looking for, then you know what tools you're supposed to use. Okay, so I'm supposed to use a hammer, I'm supposed to use this and that. Like it's the same thing here. Like if you already know what questions to ask, if you already know what you're looking for, then you can actually find what tools that you actually need. So that is something, that's my philosophy for, programming, for data science and AI in general, and just really for learning anything that's like project based. So that's our Pandas crash course. In the next episode, I'm still debating of whether the next episode should be diving deeper into data science, or if we should automatically start building our data analysis agent. We'll see. Let's see if we can build a data analysis agent. Now, of course, before we do that, we need to learn a little bit of SQL. So SQL is another way for us to query databases, and we have to learn about databases as well. We have a lot to do, but I'm excited about it. It's a very interesting industry, very new industry. It's exploding each week. So with that being said, I hope you're excited. Hope you got value from this video. Like, share, subscribe, and yeah, just look forward for more videos. It's probably going to be less weekly videos, because I'm trying to make more long quality packed videos than shorter videos. So I'm just going to experiment and see how the YouTube algorithm favors me. I don't know, we'll see. But if you want to help me out, again, like, share, subscribe. So hope you enjoyed, and that's the end of that. So done.